Okay, in this video, we're going to introduce measures of center, mean, median, and mode for a data set. So in this section, we're going to take a look at finding a central location for our data set. And in some instances, this can give you a good value of what to expect from that data set. So we'll talk about that in future videos. But first up, the one that you're probably already familiar with, which is the mean. And the mean of a data set is found by adding all the data values together and then dividing by the total number of values. So when most people use the term average, they're actually referring to the mean, but there are other averages we're going to talk about in this video as well. Some properties of the mean is that, first of all, sample means drawn from the same population tend to vary less than other measures of center. So what that means is if we have a population and we take a bunch of samples of that population, the means of those samples are going to be closer together in value than other measures of center like the median and the mode. Again, statistics is all about getting information about a population based on the samples and sampling. So in terms of the measures of center, the mean, median, and mode, the sample means are closer in value. If we look at the sample means, they tend to be closer in value to the population mean than the sample medians and sample modes are to the population median and mode. The mean of a data set uses every single value unless the mean is what's known as a trim mean. So with something like a trim mean, if you have let's say a 90% trim mean, that means you're going to take the highest 5% of the data values off and take the lowest 5% of the data values off and then recalculate the new mean of what you have. So unless we're using a trim mean, a mean is going to use every single value. And to that extent, we have an extreme value called an outlier, which is a number that's pretty far removed from the other values. So think of an outlier like the person that screws up a curve for grading a test. So let's say a statistics class, had a particularly tough test. And let's say everyone's scores were like in the 30s and 40s, and then one person got like a 95%. That one person would probably be considered an outlier because their score is way far removed from just about everybody else's. Or even flip the coin over, and let's say everybody does very well, like in the 80s and 90s, but you have one person just bomb the test, maybe got like a 15% on it. That person would probably be considered an outlier. And those outliers can drastically change the value of the mean because the mean will use every value. So what we can do to combat that is to use this trim mean, which I explained earlier. So our sample mean is denoted with an X with a bar over it, and this is read X bar. Our population mean uses the lowercase Greek letter mu, that's mu. Remember, samples variables tend to use the letters we're familiar with. Population parameters tend to use Greek letters. So to calculate the sample mean or the population mean, it doesn't really matter. You add up all your data values and divide by the number of data values that you have. So this is the Greek letter sigma. This is the capital Greek letter sigma that looks like an E. And this means in math, it means to add. So if we add all of our individual data values, so this X sub I represents an individual data value, like the first, the second, the third, all the way up to the last. Add all those values up and then divide by n, which represents the number of observations, the number of data values we have in our data set. That'll give us our mean, whether it's the sample mean or population mean, it doesn't really change. And another way of rewriting this is to use 1 over n times the sum of the data values. So either one of these two formulas will work for calculating mean. Median, on the other hand, is found by first arranging the data values from least to greatest and then selecting the one that's in the middle. So you kind of just cross out ones from the extremes, and then you kind of narrow into where the middle is. And if you have two data values, it should be data values in the middle, the median is going to be the mean of those two values. So if we end up having two values in the middle, we just take the mean of those two values, and that's your median. Otherwise, we can find the median by just crossing off and working our way into the center. So some properties of the median is going to separate the top 50% of the data from the bottom 50% of the data. In terms of why you would want to use the median, well, if you have, let's say, home prices in an area, typically they give you the median home price, which is going to be the middle of all the home prices in order from least to greatest. Um, Unlike the median typically does not change by large amounts when we include just a few extreme values. So, for instance, again, going back to the test scenario, let's say everybody does a really bad job on a test, but one person gets like a 95%. The median is going to be less susceptible to a change in value with that 95% test score in the data set. So because the median typically doesn't change by large amounts when we include a few outlier values, we say that the median is resistant. Sometimes we denote the median by an X with a tilde above it. However, most of the time we'll see either MED, whether it's capitalized or lowercase. In terms of the technology that I use and that I will use for these videos, it's a lowercase MED for median, but it really depends on your technology you're using. The mode of a data set is the value or values that occur the most. So there can be one mode, there could be no mode, or there can be many modes. Two modes is called bimodal. So we could have 2, 3, 4. You could have as many modes as you can think of. But with modes, it's the only measure of center that's applicable to qualitative data. So mean and median you can use for quantitative data, the numerical measures that have some sort of impact and significance when you add or subtract any two of them. But for qualitative data such as blood type, mode is the only measure of center. I mean, if you think about blood type, how do you add up all the blood types and divide by the number of people? Or how do you put the blood types in order? You could say alphabetical order, but that's really it's not really applicable to finding some kind of measure of center. So for blood type, mode is the measure of center that's most applicable. So example 1, let's take a look at finding some mean, median, and modes here. So the data set below represents the number of complaints I receive each week about my teaching. So 1 week I had 8, then 2, and 3, and we see all the way up all these values. Calculate the mean, median, and mode for the number of complaints. Well, for the mean, we need to find the total, and if we add up all those values, we get 50, and then there are 10 complaints listed, so my mean is 50 over 10, which is 5 complaints per week. So the mean average of this data set here is 5, which is the number of complaints per week. We need to sort them to get the median. And when we do that, if we start crossing out values, cross out the 1, cross out the 9, cross out the 2, cross out the 8, etc., and work our way down to the center, we're going to end up with a 4 and a 5 as our two middle values. So we take the mean of 4 and 5, so 4 plus 5 is 9, and 9 divided by 2 is 4.5. So the median number of complaints per week is 4.5. The mode number of complaints, which is really helpful when the data is sorted, is this is bimodal. We have 4 and 7 both occur twice, and everything else only occurs once. So we have two modes here. We have 4 and we have 7. All right, example 2, the next week I received 400 complaints. So now recalculate the mean, median, and mode. So adding this 400 into the mix, now our total is 450, and putting the 400 in there, we now have 11 data values in our data set. So 450 divided by 11 is 40.9. So a significant change from the 5 complaints per week in example 1. The median is 5. So if we start from 1, cross out 400, cross out 2, cross out 9, we'll get 5 is the one in the middle. And if you have an odd number of values in your data set, your median will be in your data set. If you have an even number, you're going to have to take the mean of the middle two. So notice in this case, the mean, unlike the mean went up quite a bit. The median, though, didn't change at all. So again, here's an example of where the median is more resistant to this extreme value of 400, way far removed in value from the others. And the mode are 4 and 7 again, so the mode in this case is resistant as well. All right, that about does it for this video. Thanks for watching. I'll see you next time.